Okay, first thing we'll be starting with the most basic in computer application, which is about number systems in computers. There are 4 different types of number systems which are varying on the basis of the possible digits that they can have in them. Firstly, the most simplest and commonly used number system is the binary number system. I'm going to denote this as BNS for short form. In this number system, there are 2 types of possible digits. One is 0 and the other is 1. This was the first discovered of the computer language. Since there are 2 possible digits, the base of this number system is 2. Secondly, the next number system is known as the octal number system. I'm going to be denoting this as ONS, and the possible digits for this number system are 0 to 7. Now if we count the numbers from 0 to 7, we will see that there are 8 possible digits. That means the base is also 8. Now the third number system is the number system we use for calculation, which is known as the decimal number system. I'm going to denote this also as DNS, and in this number system there are possible digits of 0 to 9, and thus if you count the numbers that can be written in this number system, you'll get the base as 10. And this is what we use for calculations nowadays. Now the last number system is slightly more complex, which needs to be always given an extra step when converting from either another number system to this one or this one to another number system. This is known as the hexadecimal number system. I'm going to be denoting this as HNS. This number system has possible digits from 9 to 0 or 0 to 9, and also it has letters from A to F. A in this case stands for 10 and F in this case stands for 15. So completely taking everything in the form of numbers, it will be literally from 0 to 15. So if you count the possible numbers in this, you'll get the base as 16. Now the bases are always important because you'll need the bases when you're converting from one form to another. So I'm just going to write down the bases for the first number system, the second, the third and the fourth. For the first one it was 2, for the second one it was 8, for the third one it was 10, and for hexadecimal it was 16. These will always come handy when converting from one number system to the other. Now we're going to start with the conversions from the decimal number system to binary number system first. Now there are 2 major steps when converting from the decimal number system to the binary number system, or as a matter of fact any other number system. The first step is repeated division by the base number, and secondly it's to note down the remainders which constitute the number system that the decimal number system is being converted into. The remainders you'll get are at every successive stage, and you need to make sure that you don't make a mistake in taking them down. Now when you're converting from the decimal number system to the binary number system, it's always going to be the case that you're only going to get 2 types of remainders. You have to keep this in mind, because the binary number system only constitutes 0 and 1 repeatedly in different sequences. Now we'll take an example of the number 237. This is the way we write 237 to the base 10, which means that this is from the decimal number system, because we've written to the base 10 and the number is 237. Now there's a very systematic way in which you can convert from the decimal number system to the binary number system and to the base 2. Let's start with 237. This will be for division and this will be to note down the remainders. Firstly, we start with 2, since we have to constantly divide it by the base itself. 2, we get 118, and the remainder we get is 1. And then we divide by 2 again and we get 59, remainder 0. Divide by 2 again, we get 29, remainder 1. Then divide by 2 again, 14, remainder 1. Divide by 2 again, we get 7, remainder 0. Divide by 2 again, 3, remainder 1. Divide by 2 again, you get 1, remainder also 1. And the last and most important step is that you have to divide 1 completely. So 2 multiplied by 0 is 0, the remainder will come again as 1. So this is the way you should always convert from the decimal number system into the binary number system. Now, when we have all these remainders noted down, the topmost part is known as the least significant bit and the bottommost is known as the most significant bit. Now, how we convert this into the actual binary language is that we arrange from downwards to the top. Simply speaking, the most significant bit comes first. So the order will be 1, 1, 1, 0, 1, 1, 0, 1. And we have to put this in brackets to the base 2. Now this is our answer. So we have just seen how to convert from the decimal number system to the binary number system. Simple number like 237. Now we will be converting again from the binary number system to another slightly more complex number system, which is from decimal number system to the octal number system. Again, revising the steps, we have to do repeated division of the decimal number system number by the base of the octal number system, which is 8. So it will be, let's take the same number 237 to the base 10 and let's convert it to another number which is in the octal number system, which is to the base 8. So now we take 237 and we constantly divide by 8. This is for division, this is to note the remainders at the successive stages. 8, 237, you get 29, the remainder will be 5. Divide by 8 again, 3s are 24, remainder will be 5. And then divide by 8 again, 8 zeros are 0, the remainder is 3. Note that 5 and 3 both come within the limits of the octal number system, which constitutes numbers from 0 to 7, therefore the base 8. Now again, this is the least significant bit, this is the most significant bit, and arranging it from downwards to upwards, we get 3, 5, 5 to the base 8. And this is our answer. Now we go for the hardest conversion as far as it comes to the decimal number system to others. It's a decimal number system to the hexadecimal number system. Divide 237 to the base 10 and turn it into another number which is to the base 16. Now as we remember, hexadecimal number system is composed of numbers as well as alphabets. So the first step would be to first find out the remainders, which is the completely numeric form of the hexadecimal number, and then convert it into letters and numbers. It goes something like this: 237 repeatedly divided by base 16, we get here 14, and the remainder is 13. Again divided by 16, you have to multiply it by 0 and the remainder will be 14. This is an important step now. These are both in numeric form. As we remember, A stands for 10, B stands for 11, C for 12, D for 13, E for 14, and F for 15. Now we write here H and S. This is a separate extra column. As we see, D is 13, so we just write D, and 14 is E, so we just write E. And from downwards to upwards, most significant bit to least significant bit, we arrange it. It comes as ED to the base 16, and this is your answer. So that's it for conversion from decimal number system to other number systems.